Hello everyone, this is Teacher Harold, your junior high school mathematics teacher. In this video, I'll discuss the continuation of the discussion about solving word problems involving variation. This time, I'll be discussing about the remaining variations, and these are the joint and combined variations. Let us now proceed immediately to some examples. And this is just the continuation of solving problems that I have discussed since day one of this topic. So we are now in illustrative example number 10. Suppose we have z varies jointly as x and y, and z is initially 18 when x is initially 3 and y is initially 2. So these are the initial values of these quantities. Now, if the final value of x is 9 and y is 12, find the following. The constant of variation denoted by small letter k, letter B, the equation of variation, and what would be the final value of z, and what would be the final value of z, okay, because these are the final values of x and y. Okay, for our solution, of course, we need to translate this statement. Z varies jointly as x and y. As I have discussed this before, when we say z varies jointly as x and y, it also means that z varies directly as the product of x and y. So using the constant of variation k, the translated equation would be z is equal to kxy. And from this equation, we know that k is equal to z over the product of x and y. And taking this equation, we can answer letter A, which is we are going to compute for the value of k here, the constant of variation, using the initial values of z together with x and y. And these are 18, 3, and 2 respectively. Now plugging in these values to this equation, we can find the value of k. And that is 18 over the product of 3 and 2. Now simplifying this expression, k is equal to 3. And then we proceed immediately to letter B by forming the equation of variation. So what we're going to do is we simply go back to this translated equation, we copy this one, but when it comes to k, we replace it by 3. So that the equation for letter B would be z is equal to 3xy. Then proceed to letter C. What would be the final value of z? Making use of this formed equation in letter B by substituting the final value of x and y, which are 9 and 12 respectively. So that z from letter C would be what? 3 times 9 times 12. And that will give you 324. Next, number 11, if A varies jointly as B and the square of C, and initially A is 72 when B is 4 and C is 3. Let us find the following. Again, for letter A, the value of K, the constant of variation. Letter B, the equation of variation, and then the final value of A when the final value of B and C are 3 and 4 respectively. Of course, the first part of our solution is we translate this statement, A varies jointly as B and the square of C, and that will give you A equals KBC squared. And from that equation, transforming that, solving for K, we have K is equal to A over BC squared. And taking this equation, we can solve for the value of K in letter A. And that will give, okay. Of course, we use the initial values of A, B, and C, and these are 72, 4, and 3 respectively. This one. Then, taking this equation and substitute the value of B and C, we have K, which is equal to 72 over 4 times 3 squared. And that will give you 2, because the denominator, when we simplify this, will give us 36. So 72 divided by 36 is 2. And then for letter B, forming the equation of variation, of course, we go back to this translated equation. We just copy this one, but when it comes to K, we replace it by 2. Since K is 2, therefore the equation is A is equal to 2BC squared. Okay? And from this equation, we can answer letter C, computing for the final value of A, using these final values of B and C. Again, this equation taken from letter B, A is equal to what? 2 times 3, which is the value of B, and 4, which is the value of C, squared. A is equal to 96. Next, the wind resistance, denoted by small letter r, varies jointly as the object's surface area A and the velocity, small letter b. If a car is traveling at 40 miles per hour with a surface area of 25 square feet, experiences a wind resistance of 225 newtons, how fast must a car with 50 square feet of surface area travel in order to experience a wind resistance of 270 newtons? Now let us solve this problem. So we need to translate the given statement from this problem to mathematical equation, inserting the small letter k symbol, which is, as we all know, is the constant of variation. So the wind resistance R. So that is R varies jointly as the surface area A and the velocity B. Okay, so this one right here is now translated as R is equal to K AB. And of course, from this one, from this equation, you solve for K. And your K here is equal to R over the product of A and B. Then, using the initial values of R, the wind resistance, and the surface area together with the velocity, these are 40 miles per hour, 25 square feet, and 225 newtons respectively. Okay, plugging in these three values to this equation, which is this one, we have K is equal to 225 over 25 times 40. Simplifying this side, our K would be 9 over 40. And going back to this translated equation, we form the equation of variation, okay, using the obtained value of K. And this one, from this equation, we just copy this one, but when it comes to K, we replace it by 9 over 40. And the equation of variation is now R is equal to 9 over 40 AB. Then, going back to the problem, how fast must a car with 50 square feet of surface area travel in order to experience a wind resistance of 270 newtons? So you will notice that the problem is asking for what? The velocity. Okay, so V is unknown. Okay, and the surface area together with the wind resistance, their final values are given. So, yun, okay? Now, these are the final values of the surface area and the wind resistance. So to compute for the velocity, taking this equation, so we plug in the values of r and the surface area. So this will now be the equation. You just transform this equation solving for b. We have, okay, of course, you just cancel the common factor of 270 and 9, and and what will remain from this equation is what? 30 and 1. Okay? Now, we can still cancel further because there are some common factors present from this equation. Say 50 and 40. Their common factor is obviously 10. So 40 becomes 4 and 50 becomes 5. Of course, meron pang common factor to. Let's just say 30 and 5. Their common factor is 5. So this will become 1. And 30 will become 6. So what will remain from this equation is what? 6 on the right side. And then 4 as the denominator on the right side, or this is the left side. Now, of course, you just do the cross multiplication. 6 times 4 is 24 miles per hour. So this is the required velocity from this problem. Okay? Next. We are now in the last part, the last kind of variation, which is the combined variation. So let us continue. This is now your example number 13. Z varies jointly as x and y and inversely as the square of r. If Z is initially 42, when the initial values of x and y are 14 and y 6 respectively, and r is 9, the initial value of r is 9, find the constant of variation k. Letter B, the equation of variation, and what would be the final value of z when x, y, and r are 12, 15, and 36 respectively. Of course, we translate the given statement from this example. Z varies jointly as x and y and inversely as the square root of r. So the equation using k would be z is equal to kxy over the square root of r. And from this equation, solving for k, we have k is equal to z square root of r over xy. And of course, we use this equation to compute for the value of k in letter A. And of course, we use the initial values of these four parameters. Okay, and these are z is equal to 42, x is 14, y is 6, and r is 9. Okay, so taking this equation from here, this one, and substitute the values of these four parameters or symbols. So k is equal to 42 square root of 9 over 14 times 6. And you simplify, we have 3 halves. And from letter B, in letter B, we form the equation of variation. Of course, we again go back to this translated equation, but when it comes to k, we replace it by 3 halves. Okay, since k is 3 halves, therefore the equation is what? Z is equal to 3xy over 2 square root of r. And for letter C, taking this equation, we now substitute the final values of x, y, and r, and these are 12, 15, and 36 respectively. Then compute for the value of z, and that is 3 times 12 times 15 all over 2 times square root of 36. And that will give you 45. Okay? Next. Next example under combined variation. This one, it's quite long, no? The force of attraction F between two bodies varies jointly as their masses, denoted by m sub 1 and m sub 2, and inversely as the square of the distance d between them. If the mass of the first body is 90 kilograms, and the mass of the second body is 80 kilograms, the distance between masses is 40 centimeters, or 40 times 10 to the negative 2 meters, and the gravity is equal to F. Gravity is F equals 3.37 times 10 to the negative 11 Newton meter squared per kilogram squared. Find the constant K and the equation of variation. Okay, so let us translate. So the force F between two bodies varies jointly as their masses. This one, F is equal to K m sub 1 m sub 2, and inversely as the square of the distance between these two. So this is the equation. And from this equation, transforming that, solving for K, of course, for the constant of variation K, since m is 90, m sub 1 is 90 and m sub 2 is 80 kilograms, and the distance between the two masses is 40 times 10 to the negative 2 meters, we have, okay, substitute. From this equation, we plug in the given values. This one. And we have this resulting equation. Of course, you transform this equation solving for K, we have 7.49 times 10 to the negative 11. And for the equation of variation, we just simply go back to this translated equation, but when it comes to K, you replace it by this value. And the resulting equation would be what? F is equal to K, which is 7.49 times 10 to the negative 11, m sub 1, m sub 2, all over d squared. And this is your answer. Okay? So if you don't have any question, this will end our discussion about solving problems involving variations. And we'll see you next time.